The next section of your test is going to be using a lot of algebra skills combined with the properties of quadrilaterals that we have learned to help us find some missing variables or angles or side lengths and things like that. So let me walk you through examples of that. Number 13 on your review for your Chapter 6 test gives you that you have an isosceles trapezoid. So the properties that I know right away, I like to mark them, are my base angles are the same, so the top two angles will be the same. My base angles at the bottom of that trapezoid will be the same. Isosceles meant that the two legs were congruent, and I know that since it's a trapezoid, I have parallel bases, top and bottom here. So if I'm trying to find x, I've already kind of marked that. If 78 degrees is given to me and I mark that x is the same, x has to be 78. Now I'm going to go off the idea that I have two parallel lines, and when you have two parallel lines cut by a transversal, so that leg could be thought of as a transversal, I've got 78 degrees that I figured out for x, which is right next to y. Those are consecutive interior, and consecutive interior are supposed to be supplementary, meaning they add up to 180 degrees. So 180 degrees minus that 78 is going to equal my y, which means my y value has to be 102 degrees in this isosceles trapezoid. Some similar examples, you might get a kite. In this particular kite, all you're given is that you have x degrees right here. So this one, there's nothing to figure out. You just need to remember the property that says in a kite, the diagonals are perpendicular. So if the diagonals are perpendicular, x has to be 90 degrees. In number 15, we're given a parallelogram. Pay very close attention to what you are given because that tells you what properties you can use. In a parallelogram, I get two sets of parallel sides, which tells me right away I'm going to have an alternate interior set of angles here with x and 40, and alternate interior are the same. Now, I do need to know things about parallelograms in the sense that the opposite angles are the same. So angle y is the same as this angle across from it, but I don't know what that angle is. But I can figure that out because I'm given two angles right here, 60 degrees and 40 degrees. So sometimes we need to think of the angle as a whole. Using the angle addition postulate, 40 degrees plus 60 degrees is 100 degrees, which means this entire angle across from it is 100. And the angles next to each other in a parallelogram are supposed to be supplementary, adding up to 180. So if this is 100, this entire angle has to be 80, which is the same as angle y over here, so it also is 80 degrees. And that's how these problems are going to continue as we go from question to question. In 16, you're given a rhombus. So in a rhombus, I have the added parts about all four of these sides are going to be the same. It's still a parallelogram, so all those properties still apply. But in a rhombus, I get all four sides the same, which we learned gives me two congruent isosceles triangles, which means this angle of 60 degrees is going to match this angle right next to it, which tells me x is 60 degrees. And I'm going to use the same idea that I used on the last parallelogram. If x is 60, then this entire angle is 60 plus 60, which is 120. But the angles next to each other are supposed to equal 180 degrees total. So 180 degrees minus the 120 that I know is down here leaves me 60 degrees for this entire angle, which is being represented by y. So y is also 60 degrees. Now I want to make a note here. These three angles don't always have to be the same. I could draw you another rhombus and I could say that this is 20 degrees and 20 degrees, which would be 40. So this angle ends up being 180 minus the 40, which is 140. So it's very, very unique and rare that these came up to all be 60. So don't assume that all three of these angles are the same. Very important not to make those assumptions. It just happened that way. Here, number 17, we're getting a trapezoid. But we are told that M and N are midpoints. So that means that X is the value of the mid-segment. And the mid-segment, I know, is parallel and half the sum of the two bases. So since I'm given 14 and 20, X should be equal to base 1 plus base 2, half of that, which is 17. And then the second part of the mid-segment that I know is that all three of these line segments are parallel. So if angle L is 75, so is angle HMN because they're corresponding, one interior, one exterior. So HMN is also 75 degrees. Angle NML, remember to trace that out, would be this angle, which is a linear pair with 75, and a linear pair is supposed to add up to 180. So if that whole 180 minus the 75 that I already have is going to leave me 105 for angle NML. And if I'm doing this too quickly, just try and focus on the properties that I'm using, practice the examples, and see if you can come up with the same answer. Here we get a rectangle. So again, a different quadrilateral, same properties as the parallelogram, but it has its own unique properties that the diagonals are congruent. So remember that in a rectangle, if the diagonals are congruent and the diagonals bisect, all four of these segments in the middle end up being the same. That's useful because I have four isosceles triangles inside of every rectangle. So when I'm looking for Z, I'm going to find that first. I'm using the isosceles triangle to say, you know what, if that's 35, so is Z, because those should be the same in an isosceles triangle. Don't forget the definition of rectangle, though. In a rectangle, you get all of these angles are 90. So using the angle addition postulate again, 35 plus this x should equal a total of 90. So I just have to subtract the 35 to figure out that I have a remainder of 55 degrees for x. A couple different ways you can find y, but I'm going to use the idea that this 35 is alternate interior to y, because don't forget, it's a parallelogram, and your alternate interior angles are congruent if your lines are parallel, which they are. So we get 55, 35, and 35 for question number 18. So the first few questions were just asking the basic properties. Can you use those parallel lines? Can you use those properties of rhombus, rectangle, parallelogram to create equations and find those missing pieces? I will give you some questions that require a little bit more algebra, but the properties doesn't change. This side of 3x minus y is still congruent to this side of 10, so we're just going to start by writing that down. 3x minus y should equal 10. And this side of 2x plus 3y should equal this side of 14. So 2x plus 3y should equal 14. And what I hope you recognize from your algebra class is that you're looking at a system of equations with two variables. It's set up beautifully for elimination. So what I notice is that I have a negative y and a positive 3y. So I'm going to multiply the top equation by 3. And when you do this, you got to remember to multiply all three of the terms inside that equation. So 3 times 3 is 9x, 3 times a negative y is a negative 3y, which is what I wanted. I wanted these to match up so that they would cancel out. And then 3 times 10 would equal 30. So there's my multiplication to make this able to add straight down. 2x plus 9x is 11x. 3y plus a negative 3y is no y, or nothing. And that's going to equal 14 plus 30, which is 44, which means when I divide by 11, I'm going to get x is equal to 4. And now that I know what x is equal to, I'll go back to either one of these equations and I'll say, all right, if 3 times x minus y was supposed to equal 10, but now I know that x is 4, that means 3 times 4 minus y is supposed to equal 10. So 12 minus y is 10, which means y has to equal 2. So you will have to review a little bit of algebra if you're struggling with solving systems of equations, or if you get a quadratic equation. Those are things expected of you that you'll be able to solve. Also using the algebra to work backwards, like in number 20. In number 20, it's the same theorem we used before. This base plus this base divided by 2 should equal the mid-segment. And I know it's a mid-segment because this is a midpoint connected to a midpoint that I know from these markings. So I'm just going to write that. 9 plus that other base divided by 2 is supposed to equal 14. I solved this by multiplying by 2 on both sides to cancel out the fraction, leaving me 9 plus x equals 28. Or you might prefer just to think, if 14 is half of the sum, then this 14 was half of the 28, so the 9 base plus the base of x must have added together to equal that 28. So when I subtract the 9, I can figure out that x must be equal to 19. So working backwards using the properties, same idea, just a little bit more algebra involved. Be prepared for that. Make sure you're ready. You might also need to use the Pythagorean theorem once in a while. So on this one, you have a rectangle where you're given that RE is 16 and that EC is 12. Well, don't forget that you have a right angle right here in this corner. I'm going to draw that right triangle because we're going to need it to answer this question. So you've got 16 and 12. Well, the first questions are simple. It asks for RT. Well, that's opposite the side of 12. In a rectangle, opposite sides are congruent. Same thing for TC. If the top side is 16, its opposite side is also 16. But when it asks me for RA, I got to figure that out. And what I have to remember is that RA is exactly half of the diagonal RC. And RC is the hypotenuse of that right triangle that I drew over here. So I'm going to figure out what is this hypotenuse by taking a Pythagorean theorem. 12 squared plus 16 squared is going to equal that hypotenuse squared. So 144 plus 256 is going to equal x squared. So 400 equals that x squared. And when I square root both sides, I get that 20 is equal to x. So if x is the entire hypotenuse, RA was only half of that, so RA is 10, which I accidentally wrote up here. X was 20, so half of that hypotenuse would be 10 and 10. And then TA, even though that's not on the same diagonal we were working with, you got to remember in a rectangle that all four of these segments are the same because the diagonals are the same in a rectangle. So I don't need to do more work. I know that TA is also 10 for the same reason that I found RA. So your best friend with rectangles and rhombus and squares and anything with a right angle, because kites have them too, remember, is the Pythagorean theorem. So if you ever find yourself stuck, my suggestion is try and use the Pythagorean theorem. In number 22, we have a kite. And the theorem or the property that you need to remember here is the shortest diagonal in a kite will connect for you the two congruent opposite angles. So y is the same as that 105 that the short diagonal connects it to. From here, we have to remember that there's 360 degrees total in every quadrilateral, whether it's a kite, rhombus, square, or just a regular four-sided shape. So I'm going to add up the angles that I already have. I've got a 90, a 105, and a 105, which is a total of 300 degrees. So if I only get 360 total minus the 300 that I already know, that's going to leave me 60 degrees left over for the one angle that is x. I'll do this one rather quickly, but this is not on your test. This is just a review from things that we've talked about in the past. If RG is 8 and GH is 6, if T is the midpoint, we learned a theorem that said RT and TH will be the same because it's a midpoint, but so is TG because the midpoint of the hypotenuse is the same distance from all three vertices. So this is a 6, 8, 10 Pythagorean triple, and if the whole hypotenuse is 10, then each of these pieces is 5. But again, this is not on your test, just a quick review of things that I like you to think about so you don't forget some of those theorems. And in number 24, here's that quadratic equation that I alluded to earlier in this video. You have a parallelogram, and it gives me that AE is 16, but it gives me that CE is x squared. Well, it's still a parallelogram, so these two things are equal. The diagonals get bisected. So I'm just going to write that. X squared equals 16. So the simplest way to solve this would be to square root each side, and I get x is equal to plus or minus 4. Now you might be very quick to say that negative 4 doesn't make any sense because you can't have a negative length. But remember, x is the value being squared. So we check it. Negative 4 squared is 16. It works. Positive 4 squared is 16. It works because this length is represented by that number squared. So since both numbers check for the property of that parallelogram, both of them are valid answers, 4 and negative 4. And now we're going to do the same thing for y. DE is y squared, and BE is y plus 12. So I'm going to set those equal to each other because the diagonals are bisected in a parallelogram. Now this one's a little bit different because I can't just square root like a y plus 12. So I'm thinking I'll set this equal to 0 by subtracting the y and the 12 to the other side, so I have 0 left on the right side. I could factor this, I could use the quadratic formula, I could complete the square. Pick your favorite one, but I'll promise you that most of the time I'm going to give you something that will factor. So try factoring first, and if you just don't see it, go to one of the other methods that I just mentioned. This one we're thinking what multiplies to negative 12 but adds up to a negative 1, and the two numbers I'm coming up with would be a negative 4 and a positive 3. So my factors are y minus 4 and y plus 3 would equal 0. So 4 minus 4 would make 0, so y could be 4. Negative 3 plus 3 would make 0, so y could also be negative 3. Again, don't be too quick to dismiss the negative number. If we check this, negative 3 squared, does that equal negative 3 plus 12? Well, negative 3 squared is 9. Negative 3 plus 12 is 9. It checks, so negative 3 is one of our answers. And we check the 4 as well. 4 squared is 16. 4 plus 12 is 16. 4 also works. So on number 24, while it may seem you shouldn't get negative solutions to a geometry question, it is possible because it still checks and holds true for the properties of a parallelogram. So be very careful on that.